You're listening to DeepRest. Take a deep breath, slow down, and let sleep carry you. I'm David, and tonight I'll guide you into the world of dreams.
Before the first second ever existed, before light had a direction, before space even knew how to stretch, there was nothing. Not darkness, not emptiness, not silence. Those words belong to a universe that already exists, and this was a moment before existence could even imagine itself. If someone stood there, if there could exist, they wouldn't see a void. They would see a boiling sea of possibilities. Canvas waiting for a painter whose brush had not yet been invented. Scientists later called this the quantum vacuum, but vacuum is too simple a word for something that was alive, trembling, and full of potential. It wasn't empty, it was pregnant with everything that would ever be. It was the before, the prelude to creation. And then, after an eternity without minutes, something changed. A spark, a tremor, a whisper of instability in the fabric that wasn't yet fabric. It was tiny, smaller than anything the mind can comprehend, and yet inside it lived every star that would shine, every galaxy that would grow, every life that would one day wonder where everything came from. The universe was still asleep, but it was already dreaming. What happened next wasn't a bang in the way we imagine explosions. It wasn't loud. There was no air to carry sound. It wasn't bright. There were no eyes to witness the fireworks of creation. But it was transformation. It was expansion. It was birth. 13.8 billion years ago, in a fraction of a fraction of a fraction of a second, that tiny point, smaller than a grain of sand, smaller than an atom, smaller than the idea of small, opened. It stretched. It exploded outward, not into space, but as space itself. Time began ticking, light began racing, rules emerged, gravity, electromagnetism, the forces that shape reality, all forming like the lines of a cosmic operating system booting up for the first time. The universe expanded faster than the speed of light, because light didn't yet know what speed it was allowed to travel. This was inflation, an unstoppable swelling, a balloon growing from subatomic to astronomical in less than the blink of any eye that would ever exist. In that first instant, temperatures soared unimaginably high, so hot that matter itself couldn't hold together. Pure energy roared through the newborn cosmos, chaotic, wild, free. But chaos carries the seeds of order, and order was coming. As the universe expanded, it cooled, not enough for comfort, more like cooling from infinitely impossible to merely unbelievably extreme. But with every drop in temperature, new structures could form. Particles flickered into existence, then blinked out, then reappeared, dancing in a furious storm. Quarks locked together, becoming the first building blocks of matter. A few microseconds later, protons emerged, resilient enough to survive the violence around them. These tiny warriors would become the ancestors of everything solid in the cosmos. If we could freeze the frame of the universe right now, we would see something that looked less like space and more like a glowing, swirling, radiant soup, a cosmic broth of particles colliding, merging, breaking apart, starting over again. Time passed, seconds, then minutes, which in cosmic terms were monumental achievements. As the universe reached the 3-minute mark, one of the most important chapters of existence began, the birth of atoms. Up until now, everything was too hot to stay together, but as temperatures fell, protons captured electrons, forming hydrogen, the simplest and most abundant atom in the universe. A little helium appeared too, and a trace of lithium, but hydrogen dominated. These atoms were the letters of the alphabet from which the cosmos would write its story. But the universe wasn't beautiful yet. It was dark, not darkness like an empty room, but a thick, impenetrable fog of energy and particles. Light existed, but it couldn't travel. It bounced endlessly, trapped in a cosmic storm, unable to shine freely. It would take 380,000 years before the universe cooled enough for atoms to hold on to their electrons securely. Only then did light break free. Only then did the darkness lift. This moment is called the cosmic microwave background, the first afterglow of creation, a baby picture of the universe itself. But even with light finally stretching across the cosmos, it was still a lonely place. No stars, no planets, no galaxies, just a vast ocean of hydrogen drifting through ever-expanding space. And yet, something was happening in the quiet. Gravity was waiting. Began to grow. Where there was just a little more hydrogen, gravity pulled more. Small clouds became larger ones folded into colossal ones. Slowly, silently, they collapsed inward. And inside those collapsing clouds, the universe prepared its next miracle. Pressure built, heat surged, hydrogen atoms collided so fast and so violently that they fused together. And in a flash, more brilliant than anything before, the first star ignited. Imagine the entire universe having known only darkness for hundreds of millions of years, and then, suddenly, a light flickered on. Not just one light, thousands, millions, billions. The first stars were huge, far larger than the stars we see today. Burning hot and dying fast. They were cosmic furnaces, forging new elements, carbon, oxygen, nitrogen, iron, everything needed for planets, oceans, trees, animals, and humans. Without these first stars, you and I wouldn't exist. Every atom inside your body was once inside a star. As more stars formed, they clustered. As clusters grew, were spiraled, and as spirals pulled in more matter, the first galaxies emerged. Some were elegant swirls like our future Milky Way. Others were chaotic clouds of light. At the center of many, something even stranger appeared. Supermassive black holes, behemoths millions of times heavier than the sun. They didn't just sit there, they shaped everything. Their gravity choreographed the dance of stars, pulling them into elegant formations, creating the enormous cosmic structures we see today. Now the universe was no longer a silent darkness. It was a symphony of light and gravity, expansion and collapse, creation and destruction. Galaxies drifted across the cosmic sea. Stars lived, burned, and died. Some exploded in titanic supernovas, scattering heavy elements into space, seeding new generations of stars with ingredients for life. Billions of years passed. The cosmic stage was set. The raw materials for everything, planets, mountains, oceans, forests, cells, consciousness, were drifting through the galaxies, waiting for the right moment. Waiting for a new kind of story to begin. A small, ordinary star formed in an unremarkable corner of the Milky Way. Around it, a disk of dust and gas began to swirl. Tiny grains collided, merged, grew. Over tens of millions of years, worlds formed from the chaos. One of them was different, third from the sun, blue, dynamic, restless, capable of holding oceans and atmosphere, capable of hosting something the universe had never seen before, life. But that part of the story, the part involving oceans, lightning, molecules, evolution, and consciousness, belongs to another chapter. For now, the universe had done its job. It had transformed nothing into everything. It had built atoms, forged stars, carved galaxies, and created the stage on which life would one day rise. And somewhere in the background of cosmic time, a silent truth lingered. We are the incredibly lucky witnesses of a universe that learned how to know itself. The story of everything had only just begun. When the universe had finally calmed from its early storms and the galaxies drifted gracefully across the cosmic sea, one small corner of one ordinary spiral galaxy began to prepare itself for a story unlike any other. In a quiet arm of the Milky Way, inside a swirling cloud of dust and gas left behind by long-dead stars, gravity whispered again. It spoke softly at first, pulling grains together, nudging particles closer, encouraging collisions. Millions of years passed in the silence of space as this cloud collapsed inward, spinning like a great cosmic whirlpool. At its center, temperatures blasted upward, pressures soared, atoms smashed into each other with such intensity that a new fire ignited, a fire that would burn for billions of years. That fire was our sun, a newborn star shining fiercely in the darkness, its light pushing away the remnants of the cloud that birthed it. But the real magic was happening around it. The leftover dust and gas, refusing to drift away, began to swirl into a massive rotating disk, known today as the protoplanetary disk. Inside this spinning halo, chaos reigned. Dust grains collided gently at first, sticking together through electrostatic attraction, forming clumps no larger than grains of sand. Over time, those clumps slammed into others, growing into pebble-sized fragments, then boulders, then mountain-sized bodies called planetesimals. It was a violent neighborhood, countless newborn worlds to be smashing, scattering, reforming. Some were shattered by collisions, others grew stronger after each impact. Gravity once again played the role of architect. As millions of planetesimals orbited the fiery young sun, some began to dominate their local regions, growing rapidly by devouring anything in their path. These were the planetary embryos, hungry, ambitious, shaping the destiny of the solar system. In one region far from the sun, where icy particles were abundant, giant planets took shape. Jupiter formed first, becoming a behemoth so massive it could have swallowed 13 Earths. Saturn followed, elegant with its icy rings. Uranus and Neptune crystallized in the deep cold, distant and aloof. But closer to the sun, where heat evaporated lighter elements, smaller rocky planets struggled to claim their territory. Mercury, scorched and dense, carved its orbit closest to the star. Venus, wrapped in thick, choking clouds, grew second. Mars, small and cold, lingered at the edge. And then there was Earth. Just the right distance away, just the right size, just the right composition. But the Earth was not born peaceful. Its early centuries were defined by fire, fury, and collisions that would have annihilated anything alive. Seas of magma covered its surface. Volcanoes erupted endlessly, belching toxic gases into an atmosphere thick with carbon dioxide and ammonia. Asteroids slammed into the planet regularly, carving craters, reshaping continents, bringing new minerals from the depths of space. And then came the impact that changed everything. The collision with a Mars-sized planetary body scientists now call Theia. The crash was catastrophic, a hellish explosion that blasted molten rock into orbit around the Earth. That debris, over time, cooled and clumped together, forming the Moon. Without the Moon, Earth would have been a world of chaotic rotation, violent tides, and unstable climates. With it, Earth had a partner, a gentle, stabilizing force that slowed its spin, shaped its seasons, and quietly tugged at its oceans. As Earth cooled over millions of years, the molten seas hardened into a crust. Gases released from volcanic eruptions collected to form the early atmosphere. Water vapor condensed into torrential rains that lasted for thousands of years, filling basins, carving channels, creating the first primordial oceans. But rain alone wasn't enough to make an ocean world. Something else arrived, delivered from above. Comets, loaded with frozen water, bombarded the young Earth, adding to its oceans drop by drop, impact by impact, and so the blue jewel was born. Now Earth had oceans, land, an atmosphere, and a moon. But something was still missing, the spark of life. What came next is one of the greatest mysteries in science, more magical than any myth ever told. Somewhere in the warm, shallow waters of the early Earth, perhaps in a tidal pool, perhaps near a volcanic vent, perhaps inside a droplet of water clinging to a rock, simple molecules arranged themselves in a way that allowed them to copy themselves. It was chemistry becoming biology. It was chance becoming destiny. The first replicating molecules gave birth to simple cells, prokaryotes, tiny ancient organisms that would dominate Earth for billions of years. They lived without oxygen. They fed on chemicals from the environment. They were small, but they were everywhere, and they were patient. Life did not begin with animals or plants or anything visible. Life began with microscopic pioneers quietly rewriting the surface of a planet. After hundreds of millions of years, a new kind of life appeared, cyanobacteria, small blue-green organisms capable of photosynthesis. They soaked up sunlight, they absorbed carbon dioxide, and they released oxygen as waste. At first, oxygen was toxic to most life forms. It reacted with minerals, rusting entire oceans and turning them red. But as cyanobacteria continued producing oxygen for millions of years, the atmosphere slowly transformed. Oxygen accumulated. The sky turned blue. The world changed from a toxic wasteland into a planet capable of supporting complex life. But complexity required something else too: cooperation. The next great leap happened when one cell swallowed another, not to digest it, but to form a partnership. These internalized cells became mitochondria, the powerhouses of modern cells, and this union created eukaryotes, life's first complex cells. With more energy, bigger bodies became possible. With bigger bodies, new possibilities emerged, specialized functions, teamwork, diversity, and once multicellular organisms appeared, evolution exploded with creativity. But the universe hadn't finished crafting Earth yet. Continents drifted slowly over millions of years, powered by plate tectonics beneath the surface. Oceans rose and fell. Mountains formed, eroded, and formed again. The climate shifted dramatically. Ice ages, greenhouse periods, mass extinctions. Through all of this, life persisted. It evolved, it adapted, it experimented, until one day, in a future beyond imagination, a creature appeared that could look up at the stars and wonder what they were. But before that creature rises, before humans step onto the stage, the story of life must pass through countless ages. Creatures with shells, creatures with bones, creatures that swim, creatures that crawl, creatures that walk. Life would triumph and collapse, flourish and vanish, only to rise again. And buried inside all this chaos, the ingredients for future intelligence were forming. Every star that died, every comet that crashed, every molecule that copied itself, all of it contributed to the rise of something extraordinary: awareness, the ability to ask questions, to explore, to discover, to build. But right now, in this chapter of the story, Earth is still young. Life is simple. The oceans are teeming with tiny organisms that breathe, divide, and dream nothing. They cannot yet imagine the cosmic scale of what they are part of. They are the seeds of everything. They are the ancestors of trees, insects, dinosaurs, whales, humans, technology, and dreams. The universe had taken billions of years to arrange the stage for them. Now they would take billions more to evolve into something capable of telling the story. For now, the sun shines steadily above them, warming their waters, guiding their cycles, shaping their future. And Earth, this fragile, improbable oasis, spins quietly around its star, waiting for the moment when life grows bold enough to stand, to think, to wonder, to reach beyond the atmosphere and touch the heavens. The cosmic story has moved from atoms to planets, from fire to oceans, from chaos to the beginnings of biology. But the most extraordinary transformations are still to come as life prepares to leave the sea, explore the land, dominate the planet, and eventually try to understand the universe that gave it birth. The darkness of the early universe had a peculiar weight to it, a silence so absolute that it felt less like an absence of sound and more like the universe was holding its breath, waiting for something grand to happen. For hundreds of millions of years, everything that existed was an ocean of hydrogen and helium drifting through endless blackness, an expanse so vast that even the word infinite struggled to describe it. But beneath that stillness, something was stirring. Gravity, patient and relentless, began pulling tiny fluctuations of matter into denser patches, sculpting structure from chaos. It didn't rush, it never does. Gravity is the ultimate long-term strategist, playing the slowest and most effective game in existence. And eventually, the pressure inside those dense regions reached a breaking point. Hydrogen atoms, squeezed so tightly they could no longer resist the cosmic embrace, began to fuse. And in that moment, in that breathtaking, universe-altering flash, the first stars ignited. The universe changed forever. Light carved its way through the darkness like a revelation. The first stars weren't gentle, golden suns like the one you see from Earth today. They were colossal, blinding titans, hundreds of times larger than modern stars, burning at temperatures so extreme that their very existence was an act of defiance against physics. They lived fast, burned violently, and collapsed young. But in those brief, brilliant lives, they became the first forges of creation. Inside their cores, where fusion raged with unstoppable fury, hydrogen transformed into helium, helium into carbon, carbon into oxygen, layers upon layers of heavier elements forming like the rings of a cosmic tree. Every breath of life that would one day fill the lungs of animals, every atom of gold that would adorn a crown, every molecule that would sparkle in distant oceans, it all began inside those first stellar furnaces. As these massive stars lived and died, they detonated in spectacular supernova explosions, bursts of energy so powerful they could outshine entire galaxies. When they exploded, they didn't simply fade away, they heated the universe with the heavy elements they created. Iron scattered through the void, carbon drifted, oxygen spread outward in shimmering clouds. The universe, once nothing more than hydrogen and helium, began gaining the raw ingredients needed for complexity, chemistry, and eventually life itself. From these ashes, the next generation of stars formed, smaller, steadier, more complex. And around these second-generation stars, dust and metals began weaving together, forming disks, shaping worlds, sculpting planetary systems. Creation had gone from simple to sophisticated, and it wasn't slowing down. Over hundreds of millions of years, stars clustered into vast assemblies, galaxies, sprawling cities of light swirling through the cosmos. Gravity, still the quiet architect, pulled billions of stars together into elegant spirals, chaotic ellipticals, shimmering irregular shapes, and at the heart of many galaxies, supermassive black holes emerged, monsters millions or even billions times the mass of a star, devouring matter with unstoppable hunger. Yet, paradoxically, these black holes didn't destroy galactic structure, they stabilized it. Their immense gravitational pull shaped the motion of stars, anchored galactic centers, and regulated the growth of cosmic ecosystems. The Milky Way, your home galaxy, began as a small cluster of stars and dust, slowly merging with other proto-galaxies, growing larger and more luminous with time. Every merger was violent but necessary, a cosmic acquisition strategy that built something bigger, brighter, and more complex. Spiral arms formed, stretching outward like graceful trails of starlight. Nebulae blossomed across its expanse, glowing with ionized gas, birthing new stars in colossal waves. Supernovas continued to erupt in brilliant pulses, injecting more metals into the galactic medium. The galaxy became a dynamic organism, constantly recycling, evolving, refining. And within one of the Milky Way's spiral arms, far from the chaotic, energetic core, something extraordinary was about to happen. A cloud of gas and dust began collapsing under its own gravity, flattening into a swirling protoplanetary disk. At its center, pressure and heat skyrocketed until ignition occurred, the birth of a new star, a medium-sized, stable, yellow main sequence star, the Sun. It was not the largest, nor the brightest, nor the most glamorous among the stars, but it was steady, reliable, and remarkably long-lived. And around it, particles of dust collided, stuck together, grew into pebbles, rocks, mountains, and finally planets. The inner region of the disk grew hot enough that volatile materials evaporated, leaving behind rocky worlds, Mercury, Venus, Earth, Mars. The outer region, colder and denser, allowed gases to accumulate around icy cores, forming the giant planets Jupiter, Saturn, Uranus, Neptune. Millions of smaller bodies, asteroids, comets, frozen fragments scattered throughout the nascent system. It was chaotic, violent, and noisy. Meteorites rained down like cosmic hail. Collisions reshaped surfaces. Entire protoplanets were destroyed. One such collision between the proto-Earth and a Mars-sized object likely created the Moon, a companion that would one day stabilize Earth's tilt, shape its tides, and influence the rhythms of life. Earth, initially a molten sphere of magma, slowly cooled. Volcanoes erupted relentlessly, releasing gases that began forming a primitive atmosphere. Comets may have delivered water, mixing with minerals to fill early oceans. Lightning flashed across a world still hostile but full of potential. And in those oceans, in that swirling, bubbling chemical soup, something remarkable happened. Molecules capable of self-replication formed. No one knows exactly how. It might have been through chemical gradients near hydrothermal vents, or through ultraviolet radiation striking organic compounds. But whatever the method, the result was the same, the spark of life. Over billions of years, simple molecules evolved into single-celled organisms. Cyanobacteria began releasing oxygen as a byproduct of photosynthesis, slowly transforming the atmosphere and enabling more complex life to emerge. Eukaryotic cells, those with internal structures and mitochondria, rose next, followed by multicellular organisms, each generation building upon the last. Then, around 540 million years ago, life exploded into complexity during the Cambrian explosion. Creatures with eyes, limbs, shells, and nervous systems dominated the seas. Evolution adapted, diversified, experimented. Dinosaurs ruled for over 150 million years, majestic, powerful, beautifully adapted to their world. But their reign ended abruptly when a 10-kilometer asteroid struck Earth, triggering global catastrophe. Dust cloaked the skies, temperatures plummeted, food chains collapsed. And yet from this destruction came opportunity. Small mammals, once hiding in the shadows of giants, began to proliferate. They evolved into forms of every shape and size, some returning to the water, some climbing trees, some becoming predators, others grazers. In Africa, primates developed hands capable of grasping, eyes capable of depth perception, and brains capable of problem solving. Millions of years later, some of these primates descended from the trees, walking upright on open savannas. Their brains grew larger, social structures more complex, communication more sophisticated. They learned to make tools, control fire, migrate across continents. They formed tribes, invented languages, created art, built societies. They looked up at the sky and wondered where everything came from, and eventually they built telescopes, first small, then massive, then orbital. They launched spacecraft, sent probes to other planets, detected gravitational waves, observed galaxies billions of light-years away. They discovered that every atom in their bodies was formed inside stars, that they weren't separate from the universe. They were the universe, made conscious. And in that realization, humanity achieved something extraordinary. The cosmos learned to understand itself. The universe, now billions of years into its grand unfolding, was no longer the newborn furnace of cosmic fire, nor the chaotic ocean of colliding galaxies. It had matured into a vast celestial tapestry, woven from both creation and destruction, a place where stars lived full lives, where worlds rose and fell, and where consciousness itself evolved into something capable of questioning the very cosmos that birthed it. And yet, this immense, magnificent universe was still changing, still dancing to the rhythm of physics that had shaped it since the first instant of the Big Bang. Over billions of years, stars continued to form, burn, and die in spectacular fashion, some fading gently into white dwarfs, others collapsing violently into neutron stars, and a rare few exploding with Titan-like fury into supernovae so bright they outshone entire galaxies for brief moments before leaving behind dense, spinning remnants or black holes that devoured everything in their path. These cosmic events forged elements that would someday become the iron in blood, the calcium in bones, the oxygen in lungs, the gold in crowns, and the carbon backbone of every living thing. Every atom in every life form carried the memory of a star's death. Meanwhile, galaxies merged in slow-motion cataclysms, their stars swirling together like molten fire streams, their central black holes orbiting one another before colliding in gravitational shock waves that rippled through space-time itself. The Milky Way and Andromeda, drawn together by the silent pull of gravity, gradually approached over billions of years until, in a spectacular cosmic ballet, they transformed into a single colossal galaxy, sometimes called Milkdromeda by far future scientists, where new stars ignited in dense clouds of gas stirred by the titanic merger. Across the universe, worlds formed around newborn stars, some barren, some lush, some consumed by their own suns, others evolving into vibrant ecosystems teeming with complexity. On one small blue planet, orbiting an unremarkable star near the galactic edge, life became something more than chemistry. It became aware. It began gazing at the night sky and wondering what lay beyond. Humanity, descendants of stardust and shaped by evolution's patient hand, eventually rose from caves and fire to telescopes and rockets, driven by a paradoxical mixture of curiosity and longing, the desire not just to survive, but to understand. They learned the age of their universe, mapped the cosmic background radiation, the ancient afterglow of creation, and built instruments capable of seeing galaxies billions of light years away, effectively looking backward in time. In doing so, humanity discovered something astonishing. The universe was not slowing down after the Big Bang as once assumed, but accelerating, pushed apart by a mysterious force called dark energy, an unseen pressure stretching space itself. This discovery rewrote every assumption about cosmic destiny. Some theorized that galaxies would drift so far apart that the night sky would eventually go dark, each galaxy becoming an island alone in an ever-expanding void. Others believed expansion might eventually tear apart stars, planets, and even atoms in a cataclysm called the Big Rip. Yet a few imagined a cyclical universe where expansion would someday reverse into contraction, culminating in a new singularity, a rebirth known as the Big Crunch. As humanity stepped into an era of unprecedented knowledge, they also built machines capable of thinking, artificial intelligences that could process cosmic data faster than any brain, decipher patterns in starlight, and simulate futures stretching trillions of years ahead. These AIs looked deep into the abyss of cosmic time and saw a universe destined for transformation. Stars would continue to burn out one by one, galaxies would dim, and black holes would become the last beacons of energy in a universe turning cold and quiet. Trillions of years later, even black holes would evaporate through Hawking radiation, fading into silence, leaving behind only thin clouds of photons drifting through darkness. And yet, even in this final stage, some physicists theorized that quantum fluctuations in the vacuum could ignite a new universe, a fresh Big Bang sprouting from what appeared to be nothingness, continuing the eternal cycle of creation. Meanwhile, back in the relatively young age of the cosmos, humanity began expanding beyond Earth, establishing colonies on nearby worlds, harnessing fusion energy and building megastructures like Dyson swarms around their star to capture its full power. As they ventured outward, they left not only footprints, but knowledge, libraries etched in diamond, probes drifting between the stars, AR archives encoded in particles that could survive cosmic epochs. Eventually, humanity evolved, physically, intellectually, technologically, into something almost unrecognizable from its early form, a species capable of manipulating matter at the molecular level, bending energy to its will, and perhaps even navigating the deeper layers of space-time. They were not gods, but they were no longer bound by the same limitations that once kept them grounded. With every advancement, they inched closer to understanding a profound truth. The universe was not a cold, indifferent machine, but a vast system of interconnected cycles. Where matter became life, life became thought, thought shaped technology, and technology allowed the universe to examine itself. We are the cosmos made conscious, one ancient philosopher had said, and millennia later, humanity finally understood what that meant. Even as the cosmic dark ages loomed billions of years ahead, civilizations, whether human, post-human, or entirely alien, continued studying the universe, building models of its fate, and searching for ways to outlive entropy itself. Some proposed escaping into artificial universes. Others dreamed of altering fundamental constants of physics. A few believed consciousness could endure even after matter dissolved. Whatever the ultimate answer, one truth remained constant across eons. The universe had given rise to beings capable of storytelling, capable of love, capable of fear and hope and imagination. And as long as thought existed somewhere, on a planet orbiting a distant star, inside a digital mind floating through interstellar space, or within a civilization built in the halo of a dying galaxy, The universe would never truly be silent, for even when the stars faded and the galaxies drifted apart, the echo of everything that had ever been, every explosion, every atom, every life, every question, would remain woven into the fabric of space-time like a memory too vast to erase, waiting for the next great beginning. The universe, in all its vastness, had taken 13.8 billion years to arrive at this very moment, this single sliver of existence in which a self-aware species finally looked up and understood, even if only faintly, what it truly meant to be alive in a cosmos that was once nothing and would one day return to silence. For after the rise of galaxies and the forging of atoms, after stars lived their luminous lives and collapsed into dark remnants, after planets cooled and oceans formed, and consciousness emerged from primordial randomness, the universe had woven itself into something capable of asking the very question of why it existed at all. And in the quiet moments when humanity gazed at the night sky, children pointing at constellations, scientists measuring the faint glow of the cosmic microwave background, dreamers whispering wishes to distant stars, the cosmos seemed almost to stir, as though acknowledging the unusual miracle of being observed by the very beings it once forged from the ashes of ancient suns. And as the ages continued unfolding, humanity's telescopes reached farther, their equations grew deeper, and their understanding of the infinite tapestry expanded like the universe itself. Still, even with all this knowledge, the most profound truths remained not the formulas or the distances or the physics, but the realization that everything, every galaxy, every planet, every life, every hope, was made of the same ancient particles created in that first blazing instant when existence erupted from darkness, and that in the grand quiet of the cosmos, awareness was the rarest and most extraordinary phenomenon, the universe briefly waking up to see itself. As humans sent probes into the void, their metallic messengers sailing past the planets like tiny sparks against the backdrop of eternity, they carried messages not of conquest, but of humility. Tiny plaques etched with languages and diagrams, golden records filled with songs and heartbeats, whispers of who they were and what they dared to dream, because even in the face of cosmic grandeur, humanity felt compelled to leave a mark, a sign that they had lived and loved beneath the stars, and that perhaps someone, somewhere, might one day understand. Yet for all their ambition, the cosmos remained incomprehensibly vast, a theater of creation and destruction, where new stars ignited within collapsing nebulae, where supernovae enriched the interstellar medium with elements essential for life, where dark matter held galaxies in gravitational embrace, and where dark energy pushed everything outward into a future no one could predict. And in that sprawling ocean of time and space, life on Earth was a miracle of staggering probability, so delicate that its existence bordered on the impossible, a fragile spark flickering briefly in the darkness, but one that shone with an intensity no star could rival, because it carried awareness, memory, emotion, meaning. Humans, fragile as they were, became storytellers of the universe, narrators of an epic they had only just begun to understand, and when they looked into their own origins, carbon forged in ancient stars, water delivered by comets, iron born in supernova cores, they realized that the story of the cosmos was also the story of themselves, that the universe was not simply around them, but within them, every heartbeat a quiet echo of the primordial expansion that once set everything in motion. And as they contemplated the distant future, where stars would burn out one by one, where galaxies would drift farther apart, where the universe might freeze, collapse, or tear itself apart, they felt an unexpected serenity, for they knew that existence was not defined by its length, but by its depth, and that consciousness, even if temporary, was the brightest flame the cosmos had ever produced. With this understanding, the human species continued their journey, now with a quiet reverence, knowing that everything they touched, everything they loved, everything they feared, everything they dreamed, was part of a cosmic symphony older than time itself. And in this realization, they found not despair, but an overwhelming sense of belonging, because they were not simply observers of the universe, they were participants in its unfolding, expressions of its creativity, branches of its ancient story, stretching back to the first spark of existence. And in the final reflection, when one stood beneath the night sky and felt the cold air brush their skin, when they listened to the distant hum of the universe in the silence between heartbeats, they understood that they were composed of stardust, not just chemically, but spiritually, for the cosmos had given them the capacity to love, to wonder, to search, to create, to question, to dream, and through these gifts they became, in a very real sense, the universe becoming aware of itself, embracing its own existence through the consciousness it had nurtured on a small blue world, orbiting an ordinary star in an unremarkable corner of a spiral galaxy, drifting silently through the infinite. And so the story of the universe, the story of everything, did not end with equations or predictions or theories, but with a simple, powerful truth, that from the coldest void to the warmest human embrace, from the first particle to the last fading star, existence itself was an extraordinary miracle, and to witness it, to feel it, to live even a fraction of it, was the greatest privilege the cosmos had ever bestowed upon any of its creations. And thus, in this vast and ancient universe, you, the listener, are both infinitesimal and essential, a fleeting spark and a timeless echo, a question and an answer, a moment and a memory. And though the cosmos may one day return to silence, everything you are, your thoughts, your dreams, your consciousness, will forever remain proof that for a brief, shining moment, the universe opened its eyes and saw beauty within itself.